Morning or afternoon or evening or depends.
Or whatever.
Good day.
Hello.
Yes. Hi. Good evening. Good morning. Good afternoon, gentlemen. We have Anthony and Ben with us today. How are you guys?
Good. How are you?
Well, absolutely perfect. Yeah, hey Anthony, how are you doing?
Good morning, afternoon,
Good morning.
evening.
Right. So we had a whole day of live stream today. So we started off something with SQL Maestros. I did something on extended events, and then we did a Geek talk with Greg Lowe on Enterprise Power BI, and this is the third one for the day with both of you.
Third time's a charm. That's what they say.
Yeah. All right. So we're just a few minutes. We should wait for a few minutes as participants are still joining. I think we still have about 3 to 4 minutes.
Can you just enable the screen sharing for me? Because then it will just pull up our intro slide and then whenever
Yeah,
you're
I
ready.
will. Absolutely. So
Awesome.
now it's enabled for you. For both of you, it's enabled.
Oh, not Anthony. Okay, how's that?
Big topic,
What
right?
could-
I mean, Kubernetes. Yeah, need to know Kubernetes. Yeah.
Seems like that's where everything's going.
Yes, this is your
I still
world.
don't understand it, but that's why we got Anthony.
I was just kind of I'm sure you're going to cover a lot of that. I was just reading very briefly about the basics of the Docker world, the containers, Kubernetes, and I was trying to kind of understand how good or bad it is in comparison. I should not use the word bad, but anyway, in comparison to virtualization and the hypervisor world, so to say.
Yeah, I cover that in the first module of the pre-con, where basically I do a compare and contrast of the two models, like VM-based deployment versus container-based deployment, and what are the benefits and challenges of each. And there are, right? You can't say one's better than the other, especially in the data platform universe. But they can help you solve different business challenges, right?
Right. Anthony, your voice is a little low. Not sure why.
Is that better?
Oh,
Yes.
much better.
Okay. Let me know if it's too better.
No, it's not too better. It's just okay.
Okay. Too much. Yeah, it's I get a little even though I have a hard dial on my gain for my mic, I get a little variance sometimes. I haven't been able to pinpoint the issue.
These are sometimes these settings are so, and I don't know, Windows will automatically sometimes reset. There's a little sound control panel with the input level for the microphone. And
Yeah.
let's say in a previous live stream broadcast, you've set it to 100%, and maybe you just did a restart or something, and you will see it's set back to 27 or 37.
Yeah. I saw on Twitter yesterday or the day before, I think Windows came out with has a per volume or per application volume setting. Ooh, that's too much to troubleshoot for me. I just want one, right?
Yeah. Okay, so we're just on top of the hour, and let us begin. I think as we start off, it's good to start on time, and as we start off, more people will join in. So good morning, good afternoon, good evening, depending on where you have joined from, friends. And this is the third live stream for the day, and this is under SQL Server Geeks. We did the first one under SQL Maestros and afternoon, our India time afternoon, Data Platform Geeks on Enterprise Power BI, and now I have my very good friends, Ben Weissman and Anthony Nocentino. Ben is from Germany and Anthony is from the US, and both are longtime MVPs and experts in their respective areas. And very happy, very honored to have them with us. Just to let you know that they're also speakers at Data Platform Virtual Summit. And you can visit dataplatformvirtualsummit.com to learn more what that is all about if you haven't heard about that event before. They are doing breakout sessions, they're doing training classes, full day, like 8 hours classes, and a lot more. Both of them have great experience, and that's the whole idea of this Geek Talk. It's really, there are, of course, maybe 1 or 2 slides, but it's more about we talking to each other and trying to understand the world of containers, Docker stuff, Kubernetes, and big data clusters. So this is going to be more like chat. And then we open up this Geek Talk to questions. We are streaming live on YouTube as well. So if you have questions, please use the Q&A panel. And those who are on YouTube, you can use the YouTube chat window. But I would also recommend that if you can, you should join in into Zoom, because we still have room in our Zoom control today. So you can just go to sqlservergeeks.com/live. I will request my colleague Satya, who is helping me today, to put up the link there in the YouTube chat window. So come over to sqlservergeeks.com/live, or maybe Satya can just put the Zoom link. And if you come over here, you may have better streaming experience, and you can, interact better with the speakers and with us. With this, hey, Ben and Anthony, over to you to get started. People do really want to know, what's this container world, and how are these different technologies different from one another, and what are the advantages and disadvantages? So I leave the floor to you, and yeah, let's get started.
All right. I got a question before we start. Anthony, who are you even?
Who am I? So hello, I'm Anthony Nocentino. I'm the president and founder of Nocentino Systems, where I specialize in system architecture and performance. There's all my contact info, and also had, and my email and Twitter is available there for you. Like Amit said, I've been a data platform MVP for a couple of years, and I'm also a Pluralsight author, where I author a bunch of courses on, you guessed it, Kubernetes and Linux, and that's kind of been my specialty over the last couple of years, especially since Linux and SQL Server came together in 2017, and now we're seeing Linux and Kubernetes in 2019, and that's kind of going to be the focus of most of today's conversation, and then also what Ben's going to do with the big data cluster. So over to you, Ben.
Yeah, thank you. My name is Ben Weissman. I'm from Nuremberg, Germany. As mentioned by Amit, I would love to have joined you again this year in person in India. I've been to the in-person event in Bangalore for the last 2 years, and it was splendid. So hope to be back in 2021 then. Yes, pointed out, also data platform MVP. Been working with SQL Server since SQL Server 6.5, so I've always been super passionate around SQL Server and everything around data. And one of the things that I'm passionate about, so you will also find that in my Pluralsight course, in a book that I wrote on it, and also in my training class at Data Platform Summit this year, is big data clusters. And I want to start telling you a bit what big data clusters is before we flow into the Kubernetes thing, because you see this picture, and I already tried to simplify what big data cluster is, and it still seems overwhelming because you see all these little boxes and squares and dots, and all of these are usually a couple of containers and a couple of SQL servers, and we're going to cover what a container is and what Kubernetes is in a bit. But this is a modern SQL application, if you want. So big data clusters is part of SQL Server 2019. So this is one of the ways how you can actually install it. So this is not something built on top of SQL Server, but this is SQL Server. SQL Server in a way to handle big data in a way that hasn't been there before. So it comes with so-called additional pools. The data pool, which would allow you to take, for example, if you're running a data warehouse, you have a big fact table, 100 million rows, 100 billion rows, 100 trillion rows. And the idea of the data pool is to have multiple SQL servers in your SQL Server environment, but you would not separately install them, but you would just say, hey, I want to have a big data cluster, and that big data cluster should have, as in my picture, 2 SQL Server instances in the data pool. So those would be 2 bonus SQL servers you would basically get. And then you can say, hey, take that big fact table, take those 100 million rows, push them to the data pool, and you end up with 2 identical structured tables, but these 2 tables would hold 50 million rows each, with the logic being, hey, reading 50 million rows should in theory be faster, and by the way, it's also practically faster than reading 100 million rows. Then there's something super cool in there, which is called the storage pool. It's cool for, well, multiple reasons, but the three top reasons why the storage pool is so cool is, first of all, it brings together SQL Server and Apache Spark. So two very popular technologies to work with data these days. They're now all under the same hood, and they're all being installed by your SQL Server. So again, you don't have to worry about, well, I just installed my Apache Spark. How can I get this to talk to my SQL? No, it's one thing. It comes with its own HDFS, with its distributed file system. SQL Server becomes a file server. How crazy is this? So you want to consume flat file data because you got a web server that is spitting out data. You got flat files coming in from Google Analytics because you want to kind of explore what is happening in your data estate. You don't have to load those necessarily using SSIS or PowerShell or any other ETL tool anymore. You just push them into the file server that is part of SQL Server. And then you see that little pink dot or purple dot down there that kind of sits isolated. You can even bring in external data through so-called tiering. So you could have data storage in the cloud, Azure Data Lake Store, and just mount that into your SQL Server, and therefore coming up with a completely hybrid solution, all running just one single install script. And to make all that manageable, to make all that usable, well, it was completely unacceptable, obviously, to come up with, well, maybe not unacceptable because there's still applications out there that do that. But if you would run that in a traditional way, Microsoft would probably have said, well, to deploy this, you need to install at least 25 Windows servers, and those 25 Windows servers need to be connected in this way. And then you need to install SQL Server in every single one of them, every single one with a slightly different switch and stuff. But no, what Microsoft said is, you know what, we will do big data clusters on a platform called Kubernetes. And that's the other super interesting thing about big data clusters, because these containers, and again, we're going to talk a little more about what they actually are, they run on Linux. So not only does SQL Server support Linux at this point, because it did so for a couple of years now, but still, big data clusters is a flavor of SQL Server that only runs on Linux, which is super interesting. If you think, like, if I told you 5 years back I'm going to install my SQL Server on Linux, you would have told me that's not possible. And yet here we are having a SQL Server that exclusively runs on Linux. Super cool stuff. And to get that manageable, they're using something that is called Kubernetes, which is a container orchestrator, which will basically abstract your infrastructure and give you a desired state application. But I have actually no idea what the last three things I just said mean. Can you chime in, Anthony?
Sure. So as you set up the conversation on BDC, I never even thought about, or haven't thought about, what it would be like to do a big data cluster in a traditional application deployment model. Can you imagine?
Yeah,
like
please don't think about it because it will give you a headache.
Right, but no. Let's walk through it. I'm sure we've all done it. We've gotten that 600-page PDF with the screenshots from the third-party vendor, and you're walking through setting that up over and over again. And doing that's going to be time-consuming, error-prone, and just hard, right? And that's one of the things that Kubernetes brings to the table. And I think the reasons why you see people like Microsoft placing bets on Kubernetes is because that system that Ben just described, which would probably be a 600-page PDF 15 years ago, is going to be described in code. We're going to do this. I guess we'll do this backwards, right? We'll talk about desired state first. And so what Microsoft provides to you when you deploy a big data cluster isn't a 600-page manual. It's the code that defines what a big data cluster looks like. And that's what Kubernetes does for you, is it takes that code and affects that desired state into your system, right? So you have a data pool of 2 SQL servers, a master instance with potentially 2 SQL servers. And those are the containers that support that SQL server. And there's various SQL servers in that distributed system. And so what Kubernetes will do is pull all those pieces together, connect to storage, start the containers, and give you access into these applications. And so there's where you see the infrastructure abstraction of Kubernetes, where as a deployment model, you're going to care a little bit less about your infrastructure than you did before, because what Kubernetes will do is gives you a surface area over the resources in your data center to deploy your applications. Of course, at some point in time, you're going to care where your data files live and where the IP addresses are in your data center. But when you're deploying when you're deploying your application, you're going to care a little bit less because you're just going to be a consumer of those services in the resources in your data center. At that top point there, container orchestrator, well, that's really what Kubernetes is, right? is it gives you the ability to start up containers somewhere in a data center in a defined way, right? Can I start this container on this host or node in Kubernetes terms and get access to the resources that I want and have the resources that I want, CPU, disk, RAM, networking, and things like that. And so that's kind of the core concept behind Kubernetes is it starts up containers for you. Because if you were to use, if you worked with containers so far, you've maybe done Docker run and you've exposed your application on a port. Well, doing that in an enterprise data center, you're not going to run to each server and type Docker run. Kubernetes will do that basically for you, and also uses other container runtimes as well, which we'll get into in the pre-con at DPS. So let's go ahead and jump to the next one, Ben.
Sure. So,
and so Ben, oh, okay, you got it.
I was just going to say, let's maybe take one half step back, coming back to Amit's initial question. So, what is even like the difference between a container and a traditional hypervisor? While we won't have the time to deep dive there, I would just come up with my definition, and then you can correct me, Anthony, because I'm sure there's lots of stuff missing in what I'm giving out here. But the biggest issue with a thing like big data cluster or any more complex scenario, if you would do that using traditional Hyper-V, because even with traditional Hyper-V, you would still have all these kinds of servers. It's not just
Hyper-V?
the amount of installation time. It's also the huge redundancy, the huge overhead that you get from having really full-grown, like, because every single one of these VMs that you run in your Hyper-V will have its own operating system and stuff, whereas a container, it will share the operating system from its host. And the other nice thing is that if you have multiple SQL servers that are all using the same image, you just have that one single image and spin it up into memory as many times as you need it. So also when it comes to updating, because you were describing that 600-page PDF, that was just the initial installation. If you need to upgrade that whole scenario while keeping your data, that's another 1,200-page PDF, I guess. So yeah, container is, in its easiest way, a small virtual machine that doesn't have an operating system but steals it from wherever it's running, and in exchange it becomes so much more lightweight, especially the Linux containers. We could probably start talking for hours on why Linux containers are so much faster than Windows containers. But for those of you that have ever booted a Windows machine, that have ever booted a Linux machine, you will probably get to that, and you will see that this is probably one of the reasons why Microsoft picked Linux as the platform for stuff like big data clusters. But coming back to the 5 reasons why data professionals need to know Kubernetes, let's maybe start with reason number 1. You want to take that?
So that's, yeah, I grab that. So that's kind of what we described a second ago, is Kubernetes manages the state of an application or a distributed system. So it has the responsibility of starting things up and keeping them up. So exposing services, starting containers, making sure storage is available, and keeping your system in that desired state. And not only for the initial deployment, but also for the life cycle of the application. So for example, as Ben described, we can also update an application by swapping out the container image. And what Kubernetes will do is do that for you automatically. And moreover, if you can scale, especially in stateless applications, it's very easy to scale out, meaning adding more containers, or in Kubernetes terms, pods, to support your application. So in traditional models, like I've worked in lots of e-commerce websites where for 95% of the year, they'll run on 2 web servers, and for 5% of the year, they'll run on 80 web servers, right? Basically sales peaks during the holidays. And that expansion and contraction in even with virtual machines, is still challenging. Now in Kubernetes, it's nearly as long as you have the resources available, it's nearly as easy as one command to go from 2 application pods to support your web server, to support your application to 50. In the context of SQL Server, it's a little bit different because you don't have horizontal scaling yet in traditional SQL Server, but you still have to deal with those kind of things that you would in a traditional way, with ensuring that the individual hosts supporting your container-based deployments have the resources available. Ben, is that
a big data cluster?
Yeah, I was going to kick it over to you on there. So, if you want to add in some detail about horizontal scaling there?
Well, I mean, that's kind of the thing that we had with the data pool, where you can basically just have multiple SQL servers sitting next to each other, and instead of just having a traditional cluster, because if you think of a traditional SQL cluster, it's about availability. It's not about speed or performance. even though you can just take one of these secondaries for reading and analytics purposes, it will still not give you any real boost in application performance. And this is what big data clusters, that's one of their purposes, one of their many purposes. One of the other purposes of all this is it runs in the cloud, it runs in any cloud, but it also runs on-prem. So one of the use cases for a big data cluster is to say, well, I need this kind of cloud architectured application, but I need it to run on my premises because I'm in a highly regulated industry. I'm a bank, I'm in the energy sector. There's so many examples where you could just say, well, there is no way I could ever push this to the public cloud for so many reasons.
Yeah, and even outside of horizontal scale, and even think about high availability when it comes to desired state. If you tell Kubernetes to keep a SQL Server instance online, if it crashes, it'll start up the SQL Server instance. If you delete it, it'll restart the SQL Server instance and still maintain the state of your instance. It's a very powerful construct to have when deploying applications, not only for SQL Server, but you can leverage Kubernetes across any parts of your application stack to do that. And that's kind of a business value add for CIOs and directors, where, no offense, everybody, we don't have to have a fleet of SQL Server gurus to keep SQL Server online. We can leverage the platform, Kubernetes, to keep our applications online, both on the front end and also at the data platform level.
Yeah. Well, actually, my favorite reason, and one of the reasons why I love Kubernetes is speed and consistency of deployment. And I'll give you a great example for that from my actually daily life when I'm doing all these conferences and talks with you guys. Running a environment like in the picture that we've seen for that big data cluster, that's obviously kind of expensive because you just need a bit of compute resources and stuff. So obviously, I don't want to keep that running all the time just because I'm not using it. I got one single script that will basically use a tool called kubectl, kube control, which is my interface to talk to my Kubernetes cluster itself and also to create my Kubernetes cluster then. And on the other hand, I have another tool called AZData, which I will use to deploy my big data cluster. So there's this one single script, and I will just fire it up and give it just a name. So my instance, so every single of my deployments will just be kind of like a named instance. And every single time I run that script, I just know, okay, 30 minutes later, all of these components, all of these at least 28 containers, all of these virtual machines that I need in the background, all of that will just be spun up, and every single time it will look the same. It just gives me peace of mind. And I also know, well, if something goes wrong in the data center and one of these VMs goes down or moves to another host, Kubernetes will just make sure that it will just re-kick up all these containers and pods and components wherever I need this. This is why I love Kubernetes so much, because it makes my life so much easier. In the old days, when you had like a complex demo, it took you maybe a day or so to even get it prepared. Whereas now I just know, well,
Right.
give it a name, hit enter, be done. And that, of course, also means you can easily use it. I mean, one thing is doing this for conferences where I'm just cheap and lazy and don't want to spend all the big bucks to have this up and running for the whole month by just needing it for 2 days or so. But that's obviously also in real life coming to that consistency of deployment and that speed. It also gives you mechanisms of automation, which means it is so easy that you actually do a test deployment or a test upgrade in a test scenario and then take that. It gives you DevOps for your infrastructure deployment in this case, which also is something that hasn't necessarily been there in that way for SQL Server before.
Yeah, those are the two big elements for me, is being able to do things consistently, right, over and over and over again for your deployments, and also quickly. And that isn't just about being geeky, but it's about adding value to your business, because you can do these things that traditionally would take a long time. You can do them a lot more faster, and you can do them more consistently. And so that provides value to your business so that they can do the things, whatever it is that your company does. Uh, and so being able to get to that point where you're doing the same processes over and over and over again, then you can lead towards testing and automation and automatic rollouts. Now that's kind of the next level and kind of that CI/CD DevOps world. But these are the tools that get you to there in a traditional, not traditional, but in a container-based way. You want to jump on this one, Ben?
Yeah, sure.
Sure. So the next one in our top, we'll say 5 reasons why we love Kubernetes is the ability to absorb change quickly. And we've touched on these two scenarios a little bit already with regards to scaling, so scaling horizontally, and also affecting change when it comes to rolling applications out, right? So updates, new versions, or maybe even making a modification to the platform to add additional services. In this scenario of big data clusters, I would say some parts of a big data cluster are optional, right? You don't need those core elements, but you can affect that change by modifying your deployment. And you're able to do that very, very quickly in code and repeat it in a consistent way.
I mean, kind of a combination of the two previous points is the recovery, because if I can recover my system quickly, either on an existing system by just doing a rollback because I just applied a new cumulative update and, oh, turns out this cumulative update does something slightly different and unanticipated, and they need to go back. Or my cluster, my hardware cluster just completely died, given that I can easily and consistent redeploy my existing cluster just the way it was, by just running the same script and then just pushing back in the data that was in there. That is also another way that just gets me back to where I was much faster. So, well, that whole picture of the BDC or that whole Kubernetes picture may look, oh, that's so confusing and so many components, and that must be so much more complex. While it may be complex under the hoods, I don't have to worry about that because Kubernetes kind of takes care of that for me, which kind of gets us, well, it just gets less complex. And I love less complexity because the easier something is, the more foolproof. Well, foolproof may be the wrong word because, I mean, in the end, we're all professionals, but it kind of just gets you to the point where you say, well, if there's less complexity, there's just less room for things to go wrong. And if they go wrong, it's easier to see where they went wrong and to fix them.
And Ben and Anthony, another thing that comes to my mind is the cost factor. I mean, even if theoretically we try to do what Ben was trying to explain with, let's say, multiple operating systems or multiple licenses of SQL Server, and trying to create that kind of, let's say, the breadth of the cluster, right? Or those in the traditional days when we talked about database shardings, the database like is scaling across multiple nodes. How about the cost advantage from a business value perspective using a technology like Kubernetes here?
Want to take that,
You
Anthony?
want to grab that? Yeah, sure. So there's a couple ways to approach that question. In traditional infrastructure, where I had to work with customers that had to horizontally scale, especially in physical and virtual machine-based models, you're not doing that the day you need it. You're doing that maybe 3 days before, a week before. You're probably going to conduct some load testing to ensure that you have the correct resources available to reach that workload that you're expecting. In Kubernetes, the automation allows you to scale horizontally very, very easily, as I described earlier. Moreover, in the cloud, you can just add additional nodes or additional compute resources to a cluster very, very easily, and then also contract that back very, very easily without having to get too deep into the weeds on how your infrastructure is configured. Again, back in that traditional model, where you're doing this either in your own data center or with virtual machines, you had to build automation for those elements, right? I had to go and build automation to create new VMs, update configurations, and then the cost of having to run that. So not only is it the cost of the compute time, but also the people time to manage that transition. In the Kubernetes universe, that was one of the goals, is being able to provide that horizontal scaling so that we can dynamically expand and contract the platform very, very easily, because that abstraction that the cluster provides, right, hides infrastructure, allows you to be able to consume those resources in a way that's a little more infrastructure dependent. Now, of course, like if you add nodes to a cluster, that costs money. If you add storage to a cluster, that costs money. But you can expand and contract those things a lot more easily so you can help control those costs over a time interval.
Plus also licensing model from vendors, they grow with that. So for example, if you look at what we've seen in that big data cluster picture, you've seen these 5 different SQL Server instances in there. You would still only need one SQL Server license to run this because it's all part of SQL Server, and it's all part of SQL Server Standard Edition. It comes with a couple of restrictions, obviously, so you don't just get 5 SQL servers for the price of one and can just all use them independently. But still, the complexity also gets taken out of the licensing. So you grow with your solution grows with you, and that also includes the infrastructure. So I guess we are at our top 5 reasons, but hang on, what's that? Seems like we're giving out a bonus reason.
So,
Bonus reason.
See, that's what you get when Anthony's involved. You always get a little bonus for us.
So when we start talking about this automation and deployment and expanding and contracting, one of the things that you'd have to do traditionally when perhaps adding virtual machines or adding servers is you have to track where all this stuff is. Like, how am I going to point my users to that particular service to get access to that SQL server or those 5 pods supporting the web application? And Kubernetes in the cluster provides that abstraction for you so that you can have access to those applications. And basically, you're going to get an IP and a DNS name, and Kubernetes will distribute the workload to your underlying application for you. And so as things are changing in the cluster, potentially dynamically, you don't have to reconfigure your apps. And so that kind of adds to the simplicity of the deployment in that I just say, you know what, I need to consume a SQL Server service. I'm just going to point it at this IP address. And Kubernetes is going to make sure that there's always a container or a pod at that IP address to get access to the data that that SQL Server container has. And similarly, that applies on the application side of the house, but also provides load balancing. So when I do have that scenario where I go from 2 to 50 containers to support my application, I don't have to go to my infrastructure and tell them to add 48 IP addresses to the load balancer. It just happens automatically. I point my users at that particular IP, and Kubernetes will distribute that load as defined in the deployment that I made for that application.
Cool stuff.
Very cool.
And at this point, I will, of course, just remind the audience that while we continue talking about all the goodness Kubernetes brings, please use the Q&A panel to get your questions lined up. Very shortly, we'll start taking up your questions.
Yeah, you want to shift from goodness into pain points? What are the challenges?
Yeah, we don't have time for all the challenges today. I'm sorry.
Oh, I got to skip over that part. Okay.
Yeah, but Anthony will be doing a pre-con at this year's Data Platform Geeks Data Platform Summit, a virtual pre-con. So for those of you that are not familiar, all our pre and post-cons, they will be split across 2 consecutive days. So you're still getting those full 8 hours of training, but we're splitting them into 2 chunks of 4 hours just to make it easier to digest, because we all realize, well, it is challenging just sitting in an online training for 8 hours straight. So Anthony will be doing a 0 to Hero Kubernetes pre-con, and I will be doing a post-con on big data clusters. So those should hopefully also complement each other very well.
Yeah, I think
or just
so.
contradict each other.
Right. Well, that's kind of the design of my pre-con, and we didn't do this on purpose. It just happened to work out this way. Is the idea of my pre-con is if you've never seen a container before, that's cool, right? We're going to talk about container fundamentals and how to deploy SQL Server in a container and why it's different than deploying a traditional SQL Server on a VM or on a physical host. Then once we have that under control, we're going to work into what Kubernetes is and how to get to the point where you can deploy both applications and SQL Server inside of Kubernetes. And so we'll cover the core concepts of Kubernetes, how to build your own cluster, how to store persistent data, how to deploy regular applications like web applications and things like that, and then focus on SQL Server for pretty much about 2 hours of the pre-con. At that point, then, it's where Ben would take over, because we've gotten to the point where you understand what Kubernetes is and what it takes to deploy a stateful application like SQL Server in Kubernetes. And then Ben can take over and talk about big data clusters.
Great. And audience, as Ben and Anthony just talked about their virtual class, I will just ask my colleague Satya to put down the URL. In case you're interested, you can just visit dataplatformvirtualsummit.com to learn more about the conference and these pre-con classes. They're very pocket friendly in terms of pricing. So maybe you can come on board. And let me also thank all our speakers, Ben, Anthony, and all training class speakers, pre-con and post-cons. They agreed for the recording. So not only do you attend live, but you also get a class recording. So you can always go back, watch later, and watch as many times. It's all free. So thank you for that. Yes, can we start with questions, Ben and Anthony?
Sure.
There's some questions coming in? Okay, so the first question is from Max, and he is asking, are there any labs you can go through to get to know the details? I'm referring to SL servers. Okay, SQL Server, that's what he means. I'm referring to SQL Server and Kubernetes.
So in my training class, we'll go through all of that. Basically, if you've never, like I said, if you've never seen Kubernetes before, to deploy in SQL Server in Kubernetes. And one of the cool values of being able to deploy things in Kubernetes is I'll give you the same exact code. So you will take that code and you can run that against your Kubernetes cluster to reproduce those things. Now, I do have a bunch of code on my website and on GitHub if you want to kind of get in there and dig around beforehand. And so just go to github.com and look me up on GitHub, and you'll see a lot of code available there for demonstrations on how that all pieces together.
So we search on your name, that will give them the details. I mean,
yeah. And I have there's a repo called presentations, and inside of there is where you'll find all the code.
Sure, absolutely. Right. So yeah, go to GitHub and you can search on Nocentino, and it should come up with a lot of code that Anthony has put in there, and you may access that. Okay, so we have one more question. How are Dockers different from Kubernetes?
Well, they are not, if you want to. So think of that. Docker is a platform that will allow you to run containers. And Kubernetes basically sits on top of that. It will orchestrate these containers and bring them together. So you don't have to worry if you say, well, I need 10 SQL servers, but these 10 SQL servers, they need to talk to each other and they need to know about each other, and they need my load balancer, I need my firewall, I need my DNS and all that. Kubernetes adds a level of abstraction. Kubernetes adds a level of automation on top of that to have these containers talk to each other and to have the user be able to talk to these containers. So think of Kubernetes as a technology sitting on top of that, but you can't say, well, I'm going to use this or that, because by using Kubernetes, you're automatically using containers.
Yeah, and one of the things that's happening in the Kubernetes space now is, since Kubernetes has the job of starting up containers in your data center, that container runtime, which Docker is a container runtime, it's a way to run containers, is modular. And you can actually leverage Kubernetes to run other types of containers in a Kubernetes cluster. And so that you're seeing kind of some standardization in that area inside of Kubernetes clusters. And so Docker is kind of the de facto container runtime, but that's becoming a pluggable module essentially inside of Kubernetes.
Right. So we're just waiting. If there are more questions, please use the Q&A window. I will answer this one. Okay, looks like the audience is short of questions.
They're all busy signing up for these training classes.
I hope so.
All right, so we let's wait for a minute.
Okay.
So really, Ben and Anthony, virtualization. I mean, what's really the future with hypervisors now going forward?
Well, it depends on how far forward we go. Because I mean, even with Kubernetes, you will still need some kind of infrastructure below that, and that infrastructure can be physical or virtual. So it does not. You can even have Kubernetes running on a couple of virtual machines, and then the Docker in that Kubernetes cluster. So it doesn't necessarily mean that hypervisors are going somewhere. And also, there are still great use cases where you would still just use. So think of something like a traditional file server, unless for whichever reason you don't want to use something like OneDrive and all that. You just want to have one box, and that is your file server, and that's it. That's something you can easily run in a virtual machine. So running it in Kubernetes may not add that much value to you, if any value at all. So Kubernetes is really for more complex scenarios where you actually need to orchestrate, where you have all these different components. So for example, if you think of something like a Dynamics installation, Dynamics for finance and operation, which is still, I think, 16 different Windows servers. That is stuff where I'm like, whoa, this could be just like a BDC, move into that direction. Well, porting something like Dynamics on Linux is probably not as easy as it was a SQL Server, which was on Linux already anyway, but still, there will be still lots of use cases where you just want to virtualize a server. And there's use cases where you get more complex scenarios, and this is where we're going more and more towards Kubernetes and containers and orchestration. That is my take on that.
Yeah,
Right.
so for me, when it comes to VMs and containers and the future of hypervisors, is if you look at all of the cloud providers provide a managed Kubernetes service. So Azure Kubernetes service is an example in our universe. The underlying infrastructure that supports that is still VMs. And you do get that dynamic elasticity that we described earlier because you can just say, hey, give me 5 more VMs. And you can do that very, very easily. On-prem, for me, especially customer sites, and when you're deploying SQL Server in Kubernetes, live migrations of virtual machines is still a very, very powerful concept, right? Being able to move a workload between host A and host B with zero downtime. In Kubernetes, to move a workload from host A to host B, if there were physical systems involved, it's kind of like a failover cluster, such that we have to shut down the application over here and start it up over there. It happens very quickly, but it's still a period of downtime, and there's things that occur when you shut down SQL Server and start it back up again that might be suboptimal for a workload. And so being able to move that workload to me is still a very, very powerful concept. And then obviously the elasticity of VMs, even in an on-prem scenario, because you can add different types of machines and things like that to a traditional VM-based cluster, whether it's Hyper-V or VMware and so on. So those are still part of the key design concepts of how you deploy is, VMs are physical. But I always kind of push it back on the customer and say, what are you really, really good at doing? If you're really, really good at working with VMware, then let's keep going there until there's a reason not to, right? Because you have those skills already to manage workloads.
Right, Anthony. Anthony and Ben, there is another question from Atharv, and he is asking how Kubernetes is better over OpenShift and other similar containerization softwares.
You want to
take
grab
that,
that,
Anthony?
Ben? Okay. Yeah, I think you have some context though in the BDC universe. So I spend 99% of my time in the open source vanilla Kubernetes universe. So I don't have a lot of detailed experience with OpenShift, but conceptually, what OpenShift provides you is the ability to have a vendor support your Kubernetes installation. And in some organizations, this is extremely valuable because your org needs to be able to call the vendor for support. And with straight Kubernetes at the open source project, you don't get that. And so that's a key value, regulated industries and things like that. And you see things like big data clusters going towards OpenShift because to get to those customers that require those types of support contracts is a big deal, or required, honestly, for those organizations. So better or worse, I don't know. I don't have a lot of practical experience with OpenShift, but those are the key reasons why, especially in the Microsoft universe, we're seeing folks go towards OpenShift. It's because, well, they have to, regulations.
Yeah. So my answer would have been very similar. So I wouldn't say it's better or worse because it's kind of the same thing. Because you got Azure Kubernetes services, you got KubeADM, you got Minikube, you got a Kubernetes engine within Docker Desktop. You got OpenShift, and there's a bunch more, but they essentially come down to being, well, not the exact same thing, but following the same logic. So something like OpenShift, it comes with a little extra interface and a little extra manageability. So for example, we get something that you can add to your Kubernetes cluster, which is called a service mesh. And then you got Istio, and now you got Open Service Mesh and a couple of others. So you get similar solutions for the same thing, but then they're not conflicting each other. It's just like Anthony said, am I looking for something for a commercial product, which is also commercially supported, giving me enterprise support, which is something that OpenShift does. So big data clusters is supported on the vanilla Kubernetes. So I could just go ahead and install an Ubuntu machine and install KubeADM on that, which is one of the free flavors of Kubernetes. and install my big data cluster on that, and obviously be on my own because I'm kind of out in the open source world, except for the BDC part itself. Or I could say, you know what, I'm running a nuclear plant here, so I kind of want to make sure that what I'm doing here will work out because this is mission critical. And that means I need a mission critical platform, which is not necessarily just open source. So I need something to be enterprise ready. So I'm going for OpenShift, which may be lacking a couple of features because vanilla Kubernetes will always be ahead a couple of release cycles just by the way that, but in exchange, you're lacking a little manageability that you get from the extra services and extra functionality that you get from OpenShift. So it's not better or worse. It depends on your use case if you want to go for one or the other. Obviously, also coming to how much money you want to spend on that. So if Anthony and I, if we just spin that up to show you how things work, we would probably always go for the free version, except for the infrastructure that we obviously pay for when we do something like AKS. Whereas if you would ask me, well, I'm a bank and we have like 50,000 transactions per second coming in through whichever kind of transactional system that just keeps writing and hitting my big data cluster. I need to make sure that the system is up and running 24/7, and I need to support all my analytical users and all my OLTP users. You got different requirements, and based on these requirements, it will come down to the question, what is the ideal tool and how much money would you have to spend to write this train?
Perfect. All right, friends. So yeah, I see that there are no more questions, and that's right, bang on time. We just have like 2 minutes. So Ben and Anthony, any final words before I wind up this Geek Talk?
I want to say thank you very much, Amit and team, for having us. It's always a pleasure joining you for these kinds of talks. I'm looking forward to see you and the team virtually at the summit, and I hope many of the attendees of today's Geek Talk will join either Anthony's or mine, or even better, both of our pre and post cons at the conference. Yes, and yeah, with that, thank you so much.
Right. Thanks, Ben. Anthony, any final words from you?
Just to echo what Ben said, one, thank you for having us. It's much appreciated, and being able to participate in the Data Platform Summit. Very excited to be able to do that, and hopefully we'll see some folks at our pre and post cons and also in our general sessions. So thank you so much.
Absolutely, thank you. And this was one of our first Geek Talks under SQL Server Geeks, and we hope to do more. So really honored to host both of you, and thanks for joining today's Geek Talk. Thanks for joining DPS. I'll have more opportunities to thank you as we go forward. We are still 2+ months away. And yes, the audience, ladies and gentlemen, so yeah, the link is up there, dataplatformvirtualsummit.com. Go have a look. If you want to join the summit or these pre-cons, there's a lot of training lined up there. And yes, please take a moment to thank our speakers. On the Twitter handle, at the rate SQL Server Geeks, you will see recent communications from Ben and Anthony. So if you enjoyed, and I hope, and we all hope it was worth your time today with this brief Geek Talk around Kubernetes and big data clusters. So take a moment to thank our speakers, and rest, we'll see you at the summit. Thank you and have a good day. More Geek Talks are lined up. Just go to sqlservergeeks.com/live or dataplatformgeeks.com/live, and more free training is coming up. Either way, have a good day and see you soon. Thank you, Ben. Thank you, Anthony. Thanks.
Thank you. Bye.
Thanks, everyone, for facilitating this. Goodbye and have a good day.